Okay, so as I've said, there are so many examples. You can use those examples to compute for the labor constraint, the capital constraint, the optimal amount. So these amounts are at this point, and this point means we have efficiently utilized both labor and capital, right? And you can see the difference here. Okay, the difference here means if we use all the capital to produce clothes, we should have produced this much, but we are producing this, which is because this production of clothes only will sacrifice the production of food. Okay, that's clear, because you have two products, food and clothes, and we are trying to draw the possibility the production possibility frontier for both the products. Okay, so it's clear that when you produce more of one clothes, you produce less of the other, and vice versa, right? So when you produce more of food, you produce less of clothes. When you produce more of clothes, you produce less of food, because we have two means of production, that's labor and capital, and we are trying to use this both labor and capital at its optimal level. Okay, so in either country, producing 1 yard of clothes uses 4 hours of labor. So this is another example. Okay, so you can use this example to okay, and answer this question. So this will help you. For example, in your midterm exam, I might give you question like this. Okay, you will be given the hours required to labor, the hours required of capital to produce clothes, and the hours required for capital and labor to produce food, and the total amount we have. Okay, so here total amount, you can see it says US has 200 labor and 300 capital. So it is asking what is the US labor constraint and what is the US capital constraint, and what US production bundle fully employs both factors, which is both labor and land, right? I mean labor and capital. So just exercise this using the numbers given. Okay, so I will just write you. I will give you the equations for capital and labor constraint. Okay, so capital constraint we have is capital constraint. So the capital constraint we have is capital for clothes is 2 units of capital. Okay, and plus capital for food is 3 units of capital here. Okay, so 3 capital is equal to how much? The United States has 200 for labor and 300 of capital. So this is 300, right? And labor constraint we have is total labor required, right? So total labor for clothes is 4 hours of labor. So 4 for clothes plus for food, we have 1 hours of labor required. So 1 times QF is QF, right? Is equal to total labor we have in the US is 200. Okay, so take this 2 as your labor constraint and capital constraint graphs. Okay, so from this you can compute for QF. Okay, so I will just, so QF or 3QF is equal to 300, okay, minus 2QC, right? Then QF will be equal to 300 over 3 minus 2 over 3 Q3. Then QF will be equal to 100 minus 2 over 3 QC. So this is one equation we have, right? For QC, you do the same thing. I mean, here you do the same thing. QF for labor constraint will be equal to 200 minus 4 QC, right? So from this, what is the slope? The slope for labor constraint is -4, okay? And the slope for, this is the slope, right? The slope for capital constraint is 2/3 here. This is the slope, okay? And from this, as we have said, you can also compute the maximum number of labor and capital you can produce. And we have said that you can just do, what you do is 200 minus 4 QC is equal to 100 minus 2/3 QC. Then you compute for QC, right? So just take this to the other side, under to this one, okay? So for QC, you can compute. After you compute for QC, you substitute this QC here, and you can find QF, okay? So once you can find QF, that are the two quantities of clothes and food we can produce, right? So let's see. So this is for labor constraint, okay? So the same thing we have here, right? And we have this for what? For capital constraint, okay? Then you substitute here, okay? So this is 4 minus 2/3 and 200. Then you just, this is a simple equation, right? Then the 10/3 QC is equals to 100. So QC is equals to 30, all right? So 0.3 something, okay? Not 0.3, but this means times, this is, okay, anyways, this is not writing. Okay. So I'm having problem with Wacom pad. Anyways, then from here you can see for close, and okay, now it is working. Then 30 for close we have, and food 80, right? So where does this came from? The labor constraint graph came from this equation, right? From this equation, okay? So labor constraint is 4QC plus QF is equals to 200, okay? So that is 4QC plus QF is equal to 200, okay? This is the labor constraint. And capital constraint, we have the equation is 2QC plus 3QF is equals to 300, okay? Then as we have said, substitute this one is when this is close, right? And this is food. So when close is 0, this will be 0, okay? QF will be 200, this point, okay? Then when QF is 0, this will be equal to 4QC is equals to 200, then QC will be equal to 200/4, which is 50, right? So these 2 points. So these 2 pointers are where the labor constraint lies, right? Then you do the same thing for capital constraint, which will give you this line, right? Then from these 2 lines, then you can draw the production possibility frontier of this graph, which is this one, okay? And this point is where both labor and capital are optimally utilized. This is a point where we have 30 units of clothes, and for food 80, so which is the maximum that we can produce. And what are we losing? You can compute from here, right? So this we already have computed this from here, from both the equations, okay? So I guess that is simple, right? Then from what can you say from this, for example? Which one is labor intensive and which one is capital intensive? For example, you see here it says to produce clothes you use 4 units or 4 hours of labor, right? But to produce food, you need 1 hour of labor, right? Had you only produced labor, you could have produced, I mean, only used labor, all the labor for food, then you could have produced 200, right? Because we have 200. But if it is for clothes, since it requires 4 hours, you can produce only 50 because the total amount of labor we have is 200, right? So from this, 4 hours of labor for production of clothes, 1 hour of labor for production of food. This simply tells us that clothes is, again, a labor intensive production, and this is capital intensive because 3 units of capital is required, but here 2 units of capital is required for clothes. So food is capital intensive again in this example. Okay, so here home is abundant in labor intensive to capital because it requires it has more labor to produce clothes. So these are the opportunity costs computed. Okay, so in the example, home has 2/3 of labor per unit of capital, while the foreign has half. So foreign is scarce in labor relative to capital. Okay, so when you use 2004. Okay, so what is happening is I will show you one graph for this computation. So there was new capital endowment. So capital was 3,000, right? In our previous example. Now I'm taking you back to the previous example, okay? I will not be using the Wacom because it is getting very busy. So, but you remember the equation where we have used 2QC plus QF is equal to 3,000, okay? And if I remember exactly, then it was like this, okay? Is equal to 2,000 in our first example, right? So now we are trying to increase this by 1,000 and using this as 4,000, okay? So let me talk about this theory and I will go to the graph, okay? So suppose capital endowment increases, okay, from our previous example, okay? So suppose the capital endowment has increased from 3,000 to 4,000, okay? So which means the slope for capital now constraint will shift towards the right, Because we are now adding 1,000 more capital, okay? So both endpoints of capital constraint will be larger, right? So how do output levels reflect available resources? So what change will happen if we increase the capital from 3,000 to 4,000? So new equilibrium with more capital represents the foreign, relatively capital abundant country. So assuming same technology is used across the home and foreign, okay? Because in the assumption for this model, Hexter all-in model, we have said that we consider technology and consumer taste is the same, okay? So we are assuming that whether these resources are used at home or at foreign, both are using the same technology, right? But in fact, the difference of technology can also contribute for difference of production, right? That is a reality. But our assumption here is home technology and foreign technology are the same, and home consumer taste and foreign consumer taste are the same, okay? So as I've said, maybe you can use this against this model, and you can say, because countries could differ in production because of technology and taste, consumer taste, then this model might not work at all times, okay? But as I've already said, we are building up. We started with only labor, now labor and capital, and we go on like that to see the full picture of comparative advantage, okay? Because economics is all based in comparative advantage, okay? So the discipline itself revolves around comparative advantage. That's why you need to have a very good understanding of comparative advantage. Okay, so Rybensky theory is a factor of production. As a factor of production increases, then the supply of the good that uses this factor relatively intensively increases, and the supply of the other good decreases. Okay, so when factors of production increases, then it's obvious that the supply of one of the goods will increase. But as I have already said, when you increase the production of food, for example, it implies that you have to decrease the production of clothes, right? Because we have these resources to produce only these two goods. So if we are using more resources to produce one, it means that we are going to produce less of the other product, okay? So an increase in capital causes the supply of food, goods that relatively intensively use capital, to increase, and the supply of clothes to decrease, right? And an increase in labor causes supply of clothes, because clothes is labor intensive, to increase, and supply of food to decrease, right? So I hope that is clear. So the new capital constraint equation we have is this, because we are trying to increase the capital we have from 3,000 to 4,000. So now our equation will look like this, okay? And our labor is the same. Okay, so we're using the same equation for labor, this one. I hope I got the equation, so let me check. Yes, right, so that is correct, right? So we use this for capital constraint, we use this for labor constraint in our first example, okay? So I'm trying to show you that what will happen to the production possibility frontier if we increase capital from 3,000 to 4,000. And as you know, food is the one which is capital intensive, and clothes is labor intensive. So from this, you can guess that the production of food will increase, right? Because food is the one with capital intensive. So from these two equations, then you can find the amount of food and clothes like this, okay? Then if you remember, we had 500 and 750 in our first example, okay? That is the amount of, I think, clothes and this amount of food we were planning to produce with the capital of 3,000 and labor of 2,000. So in our previous example, so we found that we can produce 500 clothes and 750, 500 food and 750 clothes. But when we increase our capital by 1,000 and making this 4,000, now you can see that production of food has increased from 500 to 1,000, right? Because because it is capital intensive and we increased capital, okay? And you can see that clothes has decreased from 750 to 500, okay? Because we have said when we increase the production of one of the goods, the production of the other good will decrease. And since clothes is labor intensive, that it is clear that the production of clothes will decrease, right? So, and the slopes and the opportunity costs will also differ. You can compute from here. So, opportunity cost of producing clothes compared to producing food was 3/2. Okay, in previous example, now it is 1/2. So you can say that the opportunity cost has increased, right? Because it was, has decreased. 3/2 is 1.5, right? So this is 0.5. So the opportunity cost has now decreased, okay? So this was our previous one, okay? This is from previous, so I will use different color. So this was from the previous and labor constraint, okay? And capital constraint was from the previous, okay? When we use 3,000 capital and 2,000 labor. And we found this was our equilibrium, where we decided that 500 of food and 750 of clothes could be produced at optimal level. Okay, so now what we have done here is we have increased capital from 3,000 to 4,000. That has shifted the capital constraint graph to the right, right? So that this is our new capital constraint, right? Constraint graph with 4,000 units of capital, right? So when we increase the capital graph or the capital constraint graph has shifted to the right. So now we have a new point, which is 1,333. I mean 1,333 for food and 2,000 for clothes, right? So you can find from this, you can compute this from 2QC plus 3QF is equals to 4,000. Okay, so when we produce only, if we produce only food, this means this will be 0. So 3QF will be equal to 4,000. Then QF will be equal to 4,000 over 3. That's why it is 1,333, right? And if we produce only clothes, this means this will be equal to 0, then which means 2QC is equal to 4,000. Then QC, quantity of clothes, will be equal to 2,000, right? That is this point, okay? So these 2 points. So this is our new capital constraint. So from this, so now the new equilibrium is here, right? Because this is the point where the capital constraint and labor constraint meet, right? And from this point, we have computed new values of production, which is 1,000 of food and down here 500 of clothes. Okay, so clothes has decreased from 750 to 500, but food has increased from 500 to 1,000. Okay, because we have increased capital from 3,000 to 4,000. Okay, so from this we can compute how much we can increase our production of clothes and food if we increased capital. Okay, so I will give you a hint. For example, in your question, I will ask you not capital, but if we increased labor from 2,000 to 5,000, then what will happen to the new quantity of food and quantity of clothes? Okay, so this is the example given with increase in capital. I want you to exercise with increase in labor. So if you increase labor, then this was the graph, the new capital, I mean, new labor graph will come like this. So now you will have a new equilibrium. Okay, so exercise using new capital. Okay, so that is increasing capital. So we have already discussed about this. And now this is a new example. Okay, so I want you to exercise this by your own. Okay, so the good part is, as I've said, there are so many examples in this chapter of the PPT file. So I want you to exercise this. Okay, 200 labor, 450 capital, and what will happen to, so determine and compare the relative abundance of the factors of production. Okay, so so you see, so it is the quantity of I mean the units required to produce food and to produce clothes are the same with the previous one, but now you have capital of this Canada is this capital 400, labor 200. Okay, so compute this. So this is the new one. Okay, this is I guess simple. Compute the quantity of F and quantity of C with the new one, and you can see the opportunity cost here. Okay, then you see capital has shifted here. So now this is the new point. Okay, so you exercise this by your own. You can determine the relative abundance opportunity cost in home, and this is for foreign, as we have already discussed. So you can see the difference in opportunity cost is higher here, because this is less. Okay. And the solution is also provided, so I want you to go through this. So let's start from here, because the previous example, I want you to read that example by yourself, okay? So the above production possibility frontier equation do not allow substitution. So so far now we were discussing that there is no substitution. Substitution in a sense, we cannot substitute labor for capital or capital for labor. Okay, we were considering these two factors of production as separate. Okay, so now from here we can see what will happen if we allow substitution of capital for labor in production. Okay, so unit factor requirements are constant along each line segment of the production possibility frontier. Then if producers can substitute either capital or land for another in the production process, then the PPF is curved or bowed. Okay, so as I've said here, when we see the graph of the production possibility frontier, because for example here is the production possibility for frontier, right? So it's not curved, or it is the curve is not doesn't have a constant slope. And if it doesn't have a constant slope, then we cannot for sure explain the opportunity cost, right? Because this has a different, its own slope, and this has a different slope, right? But we want to have one slope, and we want it to be curved, okay? So that will come with substitution, okay? So opportunity of close increases as production makes more closes. So this shows quantity of food, we have quantity of clothes. Then if the slope, I mean the graph is like this, bowed, then we can see that the production, you see, for example, if we have this quantity of food, we will have this quantity of what? Clothes, right? And if we have less, okay, around here, quantity of food, then we will have, this will be our quantity of clothes. So let's say one has, and two, like this, okay? So when we decrease the production of food, we increase the production of clothes, okay? This is what it shows. Then the opportunity cost of producing more clothes becomes decreasing and decreasing, okay? So what does the country produce? The economy produces at the point that maximizes the value of production. So now, previously we were talking, we were not talking about the value of production, okay? So now we are trying to compute for the production possibility frontier when the value of production increases or decreases, okay, depending on the value of production. So the value of production is called the ISO value, and ISO value is computed as this. V is equal to price of C, price of clothes times quantity of clothes, plus price of food, quantity of food. This is the total value from the production, right? Quantity of clothes we produce times its price plus quantity of food we produce times its price will give us the value of the production, the whole production, right? So where PC and QC are the prices of clothes and food, and the slope of the ISO value is this one, okay? So this will be the graph of the production possibility frontier will be bowed or curved, and we can easily compute for the slope of the production, okay? So if the production here, this will be the slope. If the production here, this will be the slope, right? Or if it is here, this will be the slope, which is tangent to the line or the curve, okay? So given the relative price of clothes, the economy produces at the point Q that has the highest possible ISO value line, all right? So At that point, the relative price of close equals the slope of the production possibility frontier, which equals to the opportunity cost of producing both. Then I want to remind you about the opportunity cost. Okay, a country produces a product when its opportunity cost is less or equal, usually less than the opportunity cost of production. Why equal? Because when the opportunity cost is equal, then the producers will be indifferent, which means now there is no difference either producing at home or importing those products from abroad. Okay, so when the trade-off or the opportunity cost is equals the trade-off, then the market, that will be the market price. Okay, so now we are considering a market economy, right? Capitalist market economy. And this, in capitalist market economy, then price will be determined by the demand and supply of a product, and the equilibrium price is the price where the demand and supply meet. That's the equilibrium price, and this is the price where both the sellers and the buyers are satisfied. Okay, so the trade-off in production equals the trade-off according to the market price, and market price means the equilibrium price. Okay, so producers must choose different amount of factors of production used to make both clothes and food. Okay, or clothes or food. Their choice depends on wage, rate. So these two will determine what to produce more: the wage and the rent, or the rental rate, or the wage price. Okay. Okay. I'll give you a simple example. If wage is for labor, okay, and this is for capital, this will determine how much of a product a company will produce. So, for example, if the labor is very expensive, what do you think? Whose production will decrease? Clothes or food? Okay, clothes production will decrease, right? Because we have said clothes production is labor intensive, right? So if clothes production is labor intensive and wage gets higher, okay, labor wage is higher, then we produce less clothes. Okay, but if rental is high, if capital require or capital rate is very high, then we decrease the production of food, because food is capital intensive, right? So as the wage increases relative to the rental, producers will use less labor, because labor is expensive now, and more capital. And if the rental rate is high, and since food production is capital intensive, so now they will use less capital and high labor, right? Then this will be our input possibility in food production. Okay, so the input combinations that produce 1 calorie of food, and this will be the graph. When you produce more of one, okay, you produce less of the other, like this. Okay, and assume that at any given factor prices, clothes production uses more labor relative to capital than food production uses this. Then production of clothes is relatively labor intensive, as we have said, while production of food is relatively capital intensive. So relative factors demand curve for clothes, TC lies outside of the food production. Okay, if capital is less expensive, okay, or rental is less expensive and wage is higher. Okay, so this graph just shows for production of food and clothes. Okay, so assume an economist's labor force grows, so which implies that the ratio of labor for capital increases. Okay, so assume there is assumption economy of labor force increase. What is the advantage here? if labor force increases, more clothes will be produced, right? Because clothes is labor intensive. So expansion of production possibility will be based toward this clothes, right? Because clothes is labor intensive. So at a given relative price of clothes, the ratio of labor to capital used in both sectors remains constant. To employ the additional workers, the economy expands production of the relatively labor-intensive good clothes and contracts production of relatively capital-intensive food, okay, production. So when you use, because of the economy producing more labor, you use more labor in clothes production, which means you now have to decrease the production of clothes, okay? Though this will tell you the difference in slope of production possibilities in clothes and food, okay? This much, then when labor increases, output of clothes will increase, okay? Then trade in Hexler, Hexter all-in model. So the two countries are assumed to have, as I've said, this was the assumption, right? Same cup technology and same test we are assuming, okay? So with the same technology, each economy has a comparative advantage in producing the goods that relatively intensively uses a factor of production in which the country is relatively well endowed. And with the same test, then the two countries will consume close to food and the same ratio when the food, the faced with the same relative price. So anyways, from next week, I will finish this. And also next week, we will talk about the exam, okay? So next week I will explain how or what type of questions will be there for exam, and your exam will be on May 11. Okay. So May 4 we will talk about the exam, but May 11 will be exam date. Okay. So I will talk more about what type of exam and how are you going to answer to the questions next week, okay? And we'll also finish the rest part of this chapter, okay? So next week we'll be finishing this chapter, summarizing all the other chapters, and talk about the exam for May 11, okay? So I want you to exercise, to do the exercises in each of the slides we already discussed, okay? And also don't forget to watch the videos, because the ones uploading, just wait them to finish uploading, but you have to view the videos for the attendance, okay? So don't forget to view or to watch all the videos I have uploaded, okay? So I will see you next week, okay? And thank you for having me. If you have any questions, then you can